Today we're passing it over to Zach Allen Productions, and he's going to show you how to create a Thor hammer catch effect. Part of this tutorial takes place in Blender. In case you missed it in our Rise of the Dark Side tutorials, we created a script that allows you to import camera data from Blender to HitFilm. You can find the link for that in the description.
Hello everyone, I'm Zach Allen from the YouTube channel Zach Allen Productions. Today I'll be showing you how to create a Thor hammer catch effect inspired by the Avengers films. The first step in creating this effect is recording your video footage. To make adding the 3D model easier, it is a good idea to have an actual hammer prop. Most people don't have access to a realistic prop of Thor's hammer, but a rough cardboard version will work just as well. Make sure that the cardboard prop is smaller than what you would want the digital hammer to be. The main reason we need this cardboard prop is to use it as a reference to line up the digital 3D model and manually track it into the scene. Once you have your hammer prop built, have someone off-screen toss it to you. Make sure to catch the hammer and do your best Thor or Captain America impression. It is also helpful to shoot a clean plate. This is simply a video of your scene with no one in it to be used to hide the prop hammer if it appears under the digital one. The next step is to create a 3D model to match the movement of the real hammer. This isn't the final detailed model, but a quick reference model consisting of a simple cube and cylinder set to the proper dimensions. I used a free software called Blender to create the model, and it is included in the project file. However, if you are using your own footage, this model will not match. To make your own, open Blender and delete the default cube. Press Shift-A and select Cube. Set the scale to 1. Now we can enter the dimensions of the prop in the X, Y, and Z scale settings. Press Shift-A again, but this time add in a cylinder. Set the values of the radius and depth to match those of your prop. Select the cube, and with the Move tool activated, drag it to the top of the cylinder. Finally, export this model as an OBJ file so it can be brought into HitFilm. Now that you have your footage and reference model, bring them into HitFilm and make the footage into a composite shot. Drag the reference model onto the timeline and add a wireframe effect. Adjust the settings to make the edges of the model clearly visible. You can also add a fill color effect to make it easier to see. Create a 3D point layer and parent the model to it. This will be where we animate the model to line up with the video footage. Move the point and use the orientation controls in the viewer to align the model with the prop hammer. You may notice that no matter how you rotate the model, it never lines up perfectly with the video. This is most likely because you need to match HitFilm's camera to the real camera you filmed with. You could try adjusting the camera's zoom slider to see if anything improves, but thankfully there is an equation to determine the exact value. I found this equation on a video on Mike Miller's HitFilm University channel, so to learn more about HitFilm's cameras, be sure to watch his video. After plugging in the values for your specific camera and lens, use this result as the zoom for your HitFilm camera. You will need to realign your model and change the scale, but after some trial and error, you will get the alignment extremely close. It still isn't perfect, but the real Thor hammer model will extend beyond the edges of the prop anyway. Add in a new 2D point layer. This will hold the 2D position data from a tracker placed on the actor's hand. Select your footage layer and add a new track. Place the tracker over the actor's hand and begin tracking. If the hammer goes out of frame or there is too much motion blur for the tracker, try to place it manually for those frames. Assign this tracking data to the 2D point and parent the 3D point to this 2D point. The model follows the motion, but something seems off. Moving the hammer back in Z space will fix this. I found that moving it to -2000 works well. After realigning, your hammer should follow the basic motion of the prop hammer. And now comes the time-consuming and tedious task of manually animating the position, rotation, and scale of the model to line it up with the video. There are two approaches to this in HitFilm. You can animate the rotation values or the orientation values. Typically, orientation is only used for the initial alignment of a model, and rotation is what is animated. However, the control widget in the viewer only affects orientation as of HitFilm version 14. These two controls use different methods to calculate the final value. For example, rotation can use negative values, whereas orientation is always positive. I prefer to use the on-screen control widget as it is much more intuitive, and for this shot, orientation will do the trick just fine. Scrub through the timeline and find the points where the hammer changes direction significantly. Place keyframes at these points and move your 3D point so the edges of the 3D model match the video in the same way as the frame you started on. Repeat this process for the whole shot to block out the main motion of the hammer. Next, find the points between keyframes where the hammer is most out of alignment. Adjust and continue. The amount of keyframes required depends entirely on the movement in your footage. There may be times where your hammer model overshoots its orientation between keyframes. You can add another keyframe to fix this, but it may do the same thing again between those keyframes. Try selecting those keyframes and from the right-click menu, set the spatial interpolation to linear. This will force HitFilm to go straight from one value to the next, instead of trying to make an unwanted smoother motion. This is the most time-consuming step, but it is very important to have a good manual track to prevent the hammer model from sliding around in your actor's hand. Once you have finished manually tracking the reference model, it is time to add in the real Thor hammer model. I created this model in Blender, and it is available to download for free from the project files in the video description. I have included the Blender file in addition to the OBJ files, so feel free to adjust the model and make it your own. Import the Thor hammer model into HitFilm. Add in the proper textures in the material settings. The textures I used are free from a website called CCO Textures. For the metal material, use the metal color image as the diffuse map, and the metal roughness image as the specular map. Set the shading mode to Cook Torrents. Increase the roughness and slightly increase the specular reflectivity to add some subtle reflections. Increase the diffuse reflectivity to around 50% so the model takes on some of the colors of the environment. For the metal handle material, use either of the two images as the specular map, but don't apply a diffuse map. Use similar settings to the other metal material, but make it more reflective and less rough. The handle doesn't require any textures. Use Cook Torrent shading again, but make the material rough with a slight amount of specular reflectivity. Finally, make the strap material similar to that of the handle, but even more rough and not reflective. Drag this model onto the timeline and parent it to the prop reference model. Reset the world transform controls and adjust them to position the model properly. Hide the reference model from view. You should now see a 3D Thor hammer accurately following the motion of the prop hammer from the video. And now it is time to make this hammer look more realistic. Start by opening up the material properties and enabling both ambient occlusion settings. Select the original footage to be the environment map. You may also want to enable shadows depending on the lighting in your scene. The next step is to match the lighting. This is another reason why it is helpful to have a prop to reference, as it shows how the light is hitting the object. I'll start by matching the blue light coming from the left side of the screen. Create a new light layer and change the color to blue. Make sure the light colors you use are close to white instead of being the pure color. In the top view, I'll move the light to where I think it should be. You can also use the front or side view to help position the light vertically if necessary. Now create another light. This one will be slightly yellow to match the overall lighting of the scene. Move it into position as well. Finally, I will add a white light and position it to the side of the hammer to match the bright edge on the right side of the screen. Another thing we can do to improve the realism of the model is to change the color bit depth. This is something not covered in any other tutorial on this channel, but it can make a huge difference when working with 3D models. At the top of the screen, go to File, Project Settings, then Rendering. Change the color bit depth from 8-bit integer to 16-bit float linear. Click OK, and you should see a dramatic change in how the lights affect your 3D model. You will most likely need to reposition your lights because of the different light fall-off. I recommend only using this setting to render the 3D model, and change it to one of the non-linear bit depth options for adding other effects. The light is now the right color and coming from the right directions. To make the lighting more interesting, duplicate the lights and move them around to create reflections and bright spots on the model. This will help the model feel more metallic by making more use of the specular map we added earlier. If your hammer moves a lot throughout the shot, try parenting these new lights to the model so there is always a reflection. This isn't very realistic since the real lights don't follow the hammer, but it can improve the overall look of the model. Once you are happy with how your model is looking, it is time to render it out as an image sequence to use for further compositing work. Hide your video layer and click the arrow icon next to the export button. Choose Add to Queue, then Into Out Area. This will open up the export panel. For the file type, choose PNG Sequence with Alpha. This will render a high-quality image sequence with a transparent background. Create a new folder to store all of the images and start exporting. Create a new composite shot. This is where all of the final compositing will be done, separate from the 3D scene. Import the image sequence back into HitFilm, drag the image sequence in above your video, and change the color bit depth to 16-bit float instead of 16-bit float linear. If the colors aren't quite matching, add a curves effect and tweak the curve to make the hammer fit into the scene better. Make sure that the darkest part of the hammer is the same darkness as the darkest areas in the footage. You can also add a very subtle blur effect to match the sharpness of your video. It is also a good idea to add some grain or noise onto the CG render to help it look like it was actually filmed. Try your best to match the appearance of the noise in your footage. The hammer now seems to be a part of the scene, except it is in front of the actor's hand. You now have to rotoscope the hand to place it back over the hammer. This can be done in HitFilm using masking, but I prefer to use Mocha. Add the Mocha effect to your footage and click Open UI. Create a spline around your actor's hand and track the shape. Make manual adjustments as needed. There are several other tutorials on using Mocha to rotoscope, so be sure to watch those if you are new to Mocha. You can choose to apply this mask from the Mocha settings in HitFilm, but I prefer to export the shape data and bring that into HitFilm so I can make adjustments without reopening Mocha. Export the shape data and import the composite shot it creates. Copy and paste the mask onto a duplicate copy of your footage. Adjust the mask feather settings as needed. Now you can adjust this mask inside of HitFilm using the path keyframes. However, I recommend changing all of the points to linear instead of curves to make adjusting them easier. You can also animate the feather of the mask to increase when there is more motion blur. One final touch to sell this effect is to have the hammer cast a shadow on the actor's hand. Duplicate the hand mask layer and add a drop shadow effect. Adjust the settings to get the shadow in the right position. Check Shadow Only as we only need the shadow and not the hand underneath. To make the shadow only appear on the hammer, use a Set Matte effect with the hammer layer as the source. Add a blur effect to soften the shadow. Do a RAM preview of your shot and watch through for any errors. At some points, you may see the cardboard hammer poking out from underneath the 3D model hammer. This is most likely because the motion blur on the 3D model is making the layer transparent, showing the prop in the video underneath. To fix this, we need to mask a clean plate over top of the prop hammer, but underneath the CG hammer. If you shot your footage on a locked-off tripod and have a clean plate, this is as simple as dragging in the clean plate and masking wherever the prop hammer appears. If your camera is moving, you will have to track the clean plate into position before masking. If you don't have a clean plate at all, as with this footage, you'll have to find frames where the prop hammer is not visible and use those frames to mask out the prop. This can be tricky, but since the camera is moving so fast at the beginning, it is hard to notice any differences caused by the removal process. And that's how you can create a Thor hammer catch effect using HitFilm. If you want to see more tutorials like this, remember to subscribe to the official HitFilm YouTube channel, as well as my own channel, Zach Allen Productions.
Thank you to Zach Allen for creating this tutorial for us. If you're interested in another Avengers tutorial, click the card on screen. Thanks for watching, and we'll see you all in the next video.